So we're talking about our different ways to be able to write your equation for your quadratics. You guys are very used to your standard form, your y equals ax squared plus bx plus c. We've been doing that ever since we started quadratics in 9th grade. You always put your x squared term first, then your x, and then your number. That's what we call our standard form. We have, as I said, talked about your vertex form, which is this one over here. Y equals x minus h squared plus k. The cool thing about your vertex form is right in this equation you can tell what your vertex is. It would be the point hk, so you would take the h value, change the sign of it, then you would take the k value, keeping it the way it is, and that's your vertex. You can also tell from here what your axis of symmetry is. And that would just be the vertical line x equals whatever your h value is. So x equals h. So what they want us to do is they want us to rewrite the equation in vertex form, and then they want us to state what the vertex is from the equation. So in order to rewrite it into vertex form, we've got to use completing the square. That's how we're going to accomplish it, using our completing the square method. So just like we would in normal completing the square, I'm going to subtract my 5 over to the other side. So on one side of the equal sign, I just have my x squared and my x. The other side, I'm going to have y minus 5, and then I'm going to put a space with it. And then x squared minus 2x plus our space. So far, similar steps. So what's going to be our number that goes on our space? 1. Because you take your 2, divide it in half, and then square that, so we would get a 1. So over here on my left side, I have y minus 4, because my negative 5 plus my 1 gives me negative 4. We're going to factor this side over here. That would become what squared? X minus 1 squared. So now normally in completing the square, you would take the square root of both sides here, but since we're trying to put it in vertex form, we're not going to do that. What we're going to do is we're going to add the 4 over. So we have y equals x minus 1 squared plus 4. So now our equation is in vertex form. So that was part of what we had to do. The other part of it, they wanted us to state what the vertex is. So our vertex. Again, here's your h value. It's a 1. It says a minus 1 in the parentheses. When you take it out of the parentheses, you got to change the sign, so it would be a 1. And then our y value from our vertex would be 4. It's whatever this number is here, so it's a positive 4. Yes. So there's our vertex. So let's try it again. Same directions. Rewrite the equation in vertex form and then state what your vertex is. So again, I'm going to subtract my 7 over, so I have just my x squared and my x on one side. I'm going to put my spaces on both sides of the equal sign also. So I have y minus 7 plus a space equals x squared plus 8x plus a space. What number is going to go in our space? 16. Good. Again, you take your 8, divide it in half, you get a 4. 4 squared would give us a 16. So I have y plus 9 over on the left side, because negative 7 plus 16 gives me a positive 9. How would it factor over there on the right side? X plus 4. Very good. So x plus 4 squared. So again, since we're just trying to put it into vertex form, I'm going to subtract my 9 over. So we get y equals x plus 4 squared minus 9. So there is our vertex form. So then our vertex would be the point negative 4, negative a 9. Again, when you take the 4 out, you change the sign of it, so it becomes negative 4. Negative 9 stays as negative 9. So our third example here, though, this one's a little bit different because we have a negative x squared term. You can't do completing the square if that's a negative. So what we have to do first is we're going to divide everything by -1. So I get negative y, because you even divide that by the -1. So negative y equals your x squared minus 6x. I don't have a number to move over, so I'm just going to put my spaces on both sides. What number is going to go in our space? 9. Very good. Because again, 6 divided by 2 is 3. 3 squared gives us 9. So I have negative y plus 9 equals x minus 3 squared. So I'm going to subtract my 9 over. So I have negative y equals x minus 3 squared minus 9. And we're almost in our vertex form. It's not quite vertex form yet because we've got this negative in front of our y. So yet again, we have to divide everything by -1. So now my y here is positive. I can't divide the stuff in the parentheses by -1 because the stuff in the parentheses is also squared. So if you remember your order of operations, exponents would have to happen first. So what we do is we just put the -1 in front of the parentheses. So it would become -1 times x minus 3 squared. And then your 9 turns positive. So that ends up being our vertex form. What direction would this parabola go on the graph since it's negative? This one would be pointing down. All the other two would be pointing up. This one would be pointing down. So then our vertex would be the point 3, 9. Still follows the same rules, even though it has that negative out in front. Your vertex would still change the sign of your x, so it becomes positive 3. And then 9 stays as positive 9. And then I believe this is our last one on the front, right? Yep. So we got y equals 2x squared plus 16x plus 25. I can't do completing the square yet, because what do I have to do first? Divide by 2. I can't have this 2 in front of my x squared, so I've got to divide everything by 2. So that gives me a y over 2 equals x squared plus 8x plus 25 over 2. We could use the decimal form of that instead if you prefer. What's our decimal for 25 over 2? 12.5. So let's change that to 12.5. We'll use that. I'm going to intentionally leave my y over 2 just like that, though, because that's going to remind us to do our last step at the end. So just like we would do before, I'm going to bring my 12.5 over. So I have y over 2 minus 12.5 plus a space equals x squared plus 8x plus a space. So what's going to be our number on our space? 16. So y over 2, is that going to be 3.5? All right. Equals x plus 4 squared. So what do we do with our 3.5? Yeah, subtract our 3.5 over. So y over 2 equals x plus 4 squared minus 3.5. And then we got to take care of that y over 2. So to do that, we're going to multiply everything times 2. So y over 2 now becomes just y, because those 2's would cancel. Again, I can't multiply the stuff in the parentheses times 2, so I'm just going to put it in front of it, so it becomes 2 times x plus 4 squared. And then 2 times 3.5 would become a minus 7. So there's our vertex form. Our vertex would be the point -4, 7. All right. Back here, this is something you guys did a lot in 10th grade, completing the square to write your equation of your circle. Yeah. So, I mean, it's the same thing as we were doing on the front. It's just you have to do completing the square twice. So what we have to do is we have to get our x's together. So I'm going to put x squared plus 10x. And I'm going to put a space after that. So I can do completing the square with my x's. And then I'm going to put my y's together. So plus y squared minus 6y plus a space. And that's going to equal, we had to bring our 75 over, so I have a positive 75 over here, plus 2 spaces. A space from the x and a space from the y's. So now let's do our completing the squares. So for the x's, 10 divided by 2 gives us 5. 5 squared would give us a 25. So I put a 25 after my x's, and I put a 25 on my first line on the other side. What would be our numbers for the y? 9. So now we would factor our x's, and this would factor into x plus 5 squared. Factor our y's. So we would have y minus 3 squared equals 109. So now we have it in center radius form, as they call it for our circles. They want us to state what the center is. So the center would be -5, 3. Remember, you change those signs when you take those numbers out of those parentheses, so it becomes -5, positive 3. What would our radius be? The square root of 109. Is there a perfect square that goes into that? I don't believe so either. Try 36. That's the only one that's popping in my head. 109 divided by 36. Nope. Okay, then no. So there we go. So let's try it again for our next one. Again, find the center and radius for the circle. Looking at our equation, I have a 2x squared and a 2y squared. We can't do completing the square with those being 2. So what do I have to do first? Divide everything by a 2. So as I divide by 2, I'm also going to start setting up for my completing the square. So I would get x squared minus 2x plus a space. Divided those. And then y squared plus 8y plus a space is going to equal 3 plus 2 spaces. Remember, we got to divide everything. So now we'll do our completing the square. What number goes with the x's? 1. And then with our y's would be 16. So then factoring our x's, it would be x minus 1 squared. Yep. And then y plus 4 squared equals 20. So now, got to actually answer the question. Our center would be 1, -4. Again, change your signs. Our radius would be the square root of 20, but we have to simplify that. There is a perfect square that goes into 20. What's our... Yep, so that separates into 4 and 5. So we would get 2 radical 5. If you did not simplify it, you would lose credit for that. You've always got to simplify a radical if you can. All right, so find the center radius again for the equation given there. What is our first step going to be? Divide by 4s. So I'm going to have x squared minus 6x plus a space. For my y's, I'm going to have y squared plus, thank you, 18y plus a space is going to equal 19 plus 2 spaces. All right, so what's our number for our x's? 9 and 81. So then this would factor into x minus 3 squared plus y plus 9 squared equals 109 again. Wow. I didn't really switch this up too much. So our center would be 3, negative 9, and our radius would be the square root of 109. All right, so writing equations of parabolas again. So they want us to write the quadratic function shown graph to the right in the form of y equals x squared plus bx plus c. So that is our standard form. Determine its equation first in vertex form, and then we're going to convert it to our standard form. And the leading coefficient for now is a 1. So they kind of gave us a hint. Our a is a 1 value. So first in vertex form, it's going to be y equals x minus something squared plus or minus something. So we got to figure out what those somethings are. What are the coordinates of our vertex over here? It's 1 down how many? So 1, negative 9. So that means this is going to be x minus 1 squared minus a 9. So now we have to put that in standard form, though. So that means we're going to write this out twice to do our distribution. And then we'll combine our like terms. So x times x times negative 1. So I've got x squared minus x right now. Negative 1 times x and negative 1 times negative 1. So then combining our like terms, our equation would be y equals x squared minus 2x minus 8. So that's our equation in standard form. All right, one more page. So they want to know what are the roots of the graph above, what are the zeros of the graph above, so that's meaning the graph of the last problem we just did. And they're trying to trick you with this. Roots and zeros, those are the same thing. They're just different words. They like to use those words interchangeably. Roots, zeros, and then the other one they can use for it is x-intercepts. So look back at that graph from that last page. What are our two roots? It would just be the 2 and the negative 2 and the 4. We don't put the zeros with it. So our roots are x equals negative 2 and x equals 4. So sometimes what's going to happen and again, we have seen this a little bit before, is they want you to write the equation when you're given the two roots. So we're given the roots x equals -1, x equals 3. They want us to write the equation of our quadratic from that. So in the past, the way we would do it is we would set up y equals, and we would set up our two parentheses. But then what you would have to remember is even though our root here is a -1, when I put it in the parentheses, I have to change the sign of it. Because remember before, when we were factoring and solving, we would take this x plus 1, set it equal to 0, and what would we get as our answer? You'd get the -1. So for that positive 3, you got to change that to x minus 3. And then we would multiply this out. So x times x times -3, 1 times x, 1 times -3, and that would be our final answer. We'd end up with x squared minus 2x minus 3 when we combine our like terms. There is another way of doing it, and it's using what we call the sum product rule. So here is our equation we would use using your sum and your product. So in order to do it, what you have to do first is you have to take your two roots, figure out what your sum would be. So what would -1 plus 3 give us? A 2. The product, so -1 times 3, would give us a -3. And now we just have to plug it into the equation up here. It says y equals, you start with your x squared, and then it's minus the sum times x. Well, our sum was a positive 2, so it's a -2, and then you put the x with it. And then it's plus the product. However, our product was a -3, so it's going to become a -3. And that would be your equation, which does tend to go a little bit faster than the other one did. Now, the times when the sum and the product rule work really well is when your quadratic has imaginary solution, or our complex number solutions like we were dealing with in our last unit. So they want us to write a quadratic equation that has a solution of 1 plus I. Now what happens is if one solution is 1 plus I, the other solution is 1 minus I. Because if you remember from those homework that we did for today, you would take the square root of, say, -1, but you'd always have to put the plus or minus in front of it, because when you take the square root, you have positive, you have negative. So if one of your answers has positive I, the other answer has to have the negative I. Those always go together. So if one is there, the other one's there. If it said like 2 minus 3i, you would have to have 2 plus 3i. So you always have to have the conjugate with it. So figuring out our sum, 1 plus I plus 1 minus I. What would happen to those i's as we're adding? They'd cancel, so our sum would just be a 2. Bless you. Figuring out our product, you would do 1 plus I times 1 minus I. And again, since these are conjugates, all you have to do is multiply the first two. That gives me a 1. Multiply the last two. That gives me a -I squared. Which, what is -I squared reduced to? -1. So this turns this into a plus 1. So our product would also be 2. So in this case, it just happens to be that the sum and the product are both 2. So when we go to write our equation, again, following what I have highlighted up here, y equals x squared, and then it's minus the sum times x, so minus 2x, and then plus the product, and this time our product is a positive number, so it would be plus 2. That first example, our product was negative, which is why it was minus 3. All right, let's try another one with a complex number solution. So they told us one of the roots is 1 plus I radical 2, so that means the other root is 1 minus I radical 2. The conjugates are always together. So for our sum, we would add these together, 1 plus I radical 2 plus the 1 minus I radical 2. So the I radical 2's cancel each other out, so 1 plus 1 gives us a sum of 2. It's just a coincidence, it happens to be a 2 again. So then our product, that'd be the 1 plus I radical 2 times 1 minus I radical 2. So again, since they're conjugates, all you have to do is multiply the first ones. 1 times 1. Multiply the last ones. I times I gives us I squared. Radical 2 times radical 2 would give us a 2. So you'd have I squared times 2. Which the I squared again simplifies to negative 1. So that makes this turn positive. So our product is 3. 1 plus 2 gives us 3. But it would be the 1 because this would have been a negative 2 times negative 1 makes that a plus 2. So our equation would be y equals x squared minus 2x, because it's minus the sum times x, and then plus the product, so plus 3. So that would be our equation there. Now you can go backwards. If you already have the equation, you can figure out what your sum and your product are by using these little formulas here. Sum is negative b over a, product is c over a. So for our first one here, your sum would be negative from the formula, because it's negative b over a, but our b value is negative 5. Our a is a 1, because remember your a is in front of your x squared. So what would happen with our minus negative 5? Positive. And do we have to write the over 1? No, so our sum here is 5. Our product, that would be the c value over your a, so our c is a negative 14. Our a is a 1. So what is our product? Negative 14. Yeah. But you would for, like, say the next one, we've got an a value that's not 1. But you're right, if your a is a 1, you don't really need those. So here for our last one, sum would be again negative b, so negative 11 over a, so negative 11 over 2, which what would that be as a decimal? Negative 5.5. And then our product is c over a, but our c is a negative 6. So I put negative 6 over 2, our product ends up being a negative 3.